Good afternoon, everybody. I'm André Joly. I'm the general manager of SPIX Industry, a young French company working on the introduction of smart voice assistants and voice interfaces in the industry. This presentation has been presented and prepared together with Anthony Dion from EDF. EDF is the French operator of nuclear power plants and also responsible for the dismantling and decommissioning of some of them. Anthony works in the Research and Development Department for the introduction of new technologies to help in the decommissioning of nuclear plants. Today we will discuss the introduction of voice assistants for the generation and classification of hazardous situations and safety reports on the field in real time. The objective of this presentation is to explain to you what are the goals and what the nuclear industry looks for while considering such technology. The first goal is to simplify and ease the report generation while being on the field. Field operators experiment difficulties in using digital tools because of the environment and also because of the work they have to do. And while they have difficulties in using digital tools, the quantity and the quality of the data is not really at the level that is expected by this industry. So the goal is to help the field operator to generate more data and more qualified data in real time while being on the field. At the same time, if we manage to free the hands of the operator, that means if we avoid him to carry a tablet or look at a smartphone or use a tactile screen, we will increase and improve the safety of the worker, helping him to keep the PPE that he has to wear while on the field. And finally, we will secure the end-to-end digitalization process. That means that the software that are already used by the people to make their report will be used in real time on the field so that the data will be generated, the reports will be of better quality. So the solution for that is, one of the solutions is provided by SPIX Industry. It consists in a voice interface on existing software that are already used by the workers. And the introduction of a voice interface to those software enables to free the hands of the field operator to enable him to generate reports with the voice by talking, describing what is seen, describing a situation, and this situation being stored in the software that they use in their daily operations. With EDF, for example, we work with Chameleon. We have discussions with SiteFlow, we work with Infor, with IBM, that are software that you may know in your operations. The goal of our work today is to adapt this voice assistant to the nuclear constraints and to the environment of the nuclear plants. Of course, there is noise everywhere, and it needs to be reliable, and there is no network. So we need to cut the internet wire and have a system that is efficient in such environment. So the voice assistant from SPIX Industry is embedded, works offline in noisy condition, and is operational whatever condition the user is confronted to. So today we are in an experimentation phase with EDF on different sites under the commissioning, with an interface between our voice assistant and Chameleon, which is the software used by EDF to report to generate all the reports from the site inspections. And the validation will be made for safety visit reports, which is a daily activity from EDF operators. So I thank you very much for your attention. Anthony and myself are available if you have questions. We will be happy to reply to them. And I wish you a nice day. Bye-bye.
Virtual and augmented reality are two technologies that are changing the way we use our screens, creating new and exciting interactive experiences. For 15 years, SBS Interactive has been involved in developing new and exciting technologies using AR and VR for the professional world. Working with the defense industry, the naval, the nuclear, and even some universities, it has expanded our knowledge and expertise and helped us solve unanswered problematics. Based out of Nancy, a small city in France, SBS Interactive has developed a tool that transforms a physical environment into a numeric one for maintenance, for security, for training purposes, but also for marketing. Vision is the Google Street View for professionals. How did SBS Interactive come about to create Vision? Our first hint was realizing that in the industrial world, the staff were always on the lookout for factory maps and trying to visualize where they are. And their maps weren't always up to date. Then came the 3D digital models, but with those undeniable advantages, the models weren't always very accurate. And since the projects tend to be time consuming, it came with a hefty price tag. That's when SBS Interactive created Vision to be the complementary brick between the blueprints and the 3D designs. The goal was to stay as accurately possible to the real world. It can be operated simultaneously by all the staff. It's also a collaborative platform where users can create new projects, add documents, or link it to other platforms or applications. Vision lets you navigate the interior as well as the exterior of your factory using high-resolution 360 photos or 3D scans. Vision is a supervision tool that you can use while in the office, from the operation room, or even while on a mission on site. You can visualize instantly using 360 photos and have access to all the necessary information and digital tools through a laptop, a touchpad, or even a smartphone. It helps the maintenance staff understand all the aspects of the repairs that need to be done, to know all the security instructions, but also get informed on any radiological risk. Vision will accompany the newcomers during their first hours so that they can familiarize themselves with different environments of the factory. Therefore, they will be operational faster and we can limit the chances of error. Furthermore, the new apprentices will have access to tutorial videos accessible through Vision to pick up the good habits of the trade. Vision was created to handle security on big-scale projects, nuclear sites, or even industrial plants. Quickly enough, Vision became the library that hosted easy access to all the technical information. Then we created a link between Vision and computerized maintenance management systems, also known as CMMS, to be able to identify all the equipment, the history of all the maintenance staff intervening on each instrument, and a documented maintenance memo. It can facilitate and improve the maintenance of the equipment, but also inform quickly the staff about any malfunctions. Vision also integrates a mode with a supervision over a site, with an update on all configurations and thus have the history of all the modifications. SBS Interactive offers the option of hosting all the data on our own servers, but considering the high importance of the data of our clients, we can provide the option of hosting everything on the company servers. For more than 15 years, SBS Interactive has been developing the Vision software to meet the security constraints of our nuclear and defense customers and guarantee a high level of confidentiality. In 2023, we will bring a new function to Vision, the possibility to add radiological zones not only on the maps but also on the 360 degrees photos. Indeed, the radiation protectionist will be able to add radiological measurement points directly and easily on the 360 degrees photos. It's very important to know exactly where the radiological risk is in a room and what is the importance of that risk, and what better way than to visualize it. Moreover, as Vision is shared with all the teams, users can know the latest radiological values measured and thus avoid unnecessary risks and take all the precautions. Thank you.
Ladies and gentlemen, it is a great honor for me to share with you our Framatome experiences regarding solutions for predictive maintenance and asset management. I am Dr. Fomi, Senior Expert and Product Manager at Framatome GmbH. My presentation today is structured as follows. First, I will summarize the motivation why we need data-driven maintenance and asset management. Then, I will give an overview of our product and services at Framatome Lifetime Management. And finally, I will present our Framatome solution for data-driven maintenance and a smart asset management, the so-called KEDIS system. Problem challenge of plant operators. All power plant operators have the same problems. They have a huge number of industrial assets like pumps, valves, pipes, and heat exchangers. Due to some constraints like design, manufacturing mistakes, and or operational loads, etc., some production relevant power plant assets can fail earlier than expected. And as consequences, they can reduce the productivity and cause a higher operational cost. So, to improve the productivity of the plant and at the same time reduce the operational cost, power plant operators have to collect equipment data. The first objective of the data collection is condition monitoring for early fault detection. The second objective, the data analysis for problem investigation and confirmation. The third objective, the diagnosis of critical severe problems, the estimation of the rest time to failure, and the recommendation of remedial actions. The fourth and last objective is to verify the correctness of the maintenance activities and the accuracy of the diagnosis. The expected gains from a smart asset management are better asset lifetime control, better plant maintenance and engineering activities, reduce operational cost, optimize productivity, optimization of operation and processes, better integration of knowledge and experiences. So now, what's the Framatome solution? Framatome Lifetime Department offer product and services for data collection, condition monitoring, diagnostic, and data-driven maintenance. We have monitoring solution for the reactor coolant system based on vibration monitoring, acoustic loose part monitoring, and leakage monitoring. These solutions are commonly requested by the safety regulation. In addition, we have monitoring diagnostic solution for rotating machinery like pumps and non-rotating machinery like pipes, heat exchanger, as well as solution for motor operated control valves. Finally, we also offer fatigue monitoring system in the name of FAMOS-E. As you can see, all of our M&D system acquire, monitor, and store different kind of sensor data. And the data of our M&D can be exported as condition and or process data using standard communication interfaces. To improve the intelligence of our M&D system, we have been developing a data analytics platform solution called KEDIS for several years. This solution is currently used in two ways. Internally at Framatome as a standalone system, externally in power plants in combination with existing power plant M&D system, as you can see on the slide. So, KEDIS is a kind of configurable data storage and digital intelligence that automatically transform collected equipment data into diagnostic information and analytic insight for decision making and plant asset optimization. KEDIS required measurement data like condition and process data as well as operational logs or maintenance report. These data, also called raw data, are collected into the KEDIS data storage. Then the raw data are transformed in diagnostic information of future data using signal or natural language processing. After that, the analytic insight like anomaly detection, fault pattern recognition, rule estimation are derived from the feature data using basics or advanced data analytics models. Finally, all results are put at the disposal of engineering teams in form of customizable apps, dashboard, and or report. This, the last slide shows how the CADIS data are delivered to engineering teams. Using plant supervision apps, plant operator and maintenance planners have at their disposal an online information system displaying required analytics and feature data of the CADIS system, helping them to understand, operate, and maintain the plant equipment better and make faster, more reliable decisions to reduce the risk. Using visual analytics tools like Jupyter Notebook, data scientists and data experts can access all CADIS data for data exploration, data understanding, and analytics model review and or creation. Using expert tools, diagnosticians like pump expert, valve expert, primary circuit expert can review all data available inside the CADIS system for problem investigation, diagnosis, prognosis, and recommendation of remedial action. Finally, to be mentioned, all data inside the CADIS system can be put at the disposal of connected third-party system, the so-called CADIS data export, which is not shown here. Many thanks.
Hello, I'm Gael Patton. I'm co-founder at Icohup. I'm very pleased to share you at this virtual conference some results about the real-time monitoring for radiations using 4G networks in nuclear facilities. The aim of Icohup is to provide connected radiation sensors and software to monitor in real time every radiations. Our software are based on cloud technology and can be deployed on nuclear facilities as civilian facilities as hospitals, for example. Each of our sensors are based on 3 points. The first one is quality measurements, second one is connectivity, and the third one is cybersecurity. Box is our main sensors, which is designed for ambient dosimetry. It's a fixed sensors, which is connected for different applications in nuclear facilities and connected to 4G networks. We also provide a surveymeter, which are connected to smartphones, which allow very high traceability and geolocation of each measurement, which is very good for the improvement of quality in terms of radiation protection. We also provide electronic personal dosimeters, which are designed for real-time measurements, improving the quality of measurement thanks to gamma spectrometry inside of the electronic personal dosimeter. Each of these sensors has airborne sensors with drones or other spectrometers. All these data are collected in real time in our software, which is called Web, which allow several dashboards, real-time alerts, all alerts thresholds which can be configured. We also have all this data log of all your measurements, function of mappings, of course data exports and other functionalities. I want to share you 4 use cases in this conference. The first one is environmental monitoring. Our nuclear facilities, lots of passive dosimeters controlled with surveymeters are done. We propose to replace this stuff with our box, which is connected ambient dosimeters, which allow the limitation of waste time and also the capability to detect all the events in real time. The second point is all the measurements which are done with surveymeters on the storage areas, mostly on the perimeters of the storage areas. It takes lots of time without any information about the real-time measurements. So we propose to replace this kind of surveymeters and this time by ambient dosimetry in real time, which allow to time saving and real-time alerts in case of accidents. The third use case is the hotspots in case of unit shutdown or material transfers in nuclear facilities. So we propose to track the dose rate with our RIM box. It's allowed to improve the traceability and responsiveness in case of abnormal situations. The last use case is trying to monitor the flowing of filters, valves, or other elements. Usually, for example, the filters are removed when it's full in terms of mechanical point of view. We propose to monitor each of these elements with our real-time sensors, allow to replace it with the dose rate is coherent with the regulations, and to not improve the amount of waste with high activity, and allow something more easy to treat at the end of the process. All these use cases are allowed because our sensors are very easy to deploy, quite low cost considering the technology we propose. We have several feedbacks about the using of our sensors in nuclear facilities. It's of course confidential information, so I really want just to focus on global feedbacks. About environmental monitoring, the feedback shows that there is an increase in time reactivity in case of events of radio protections. About the budget, it shows that there is money saving from 24 months of use of our systems. The second feedback is about the monitoring of radiation in a corridor during a transfer of radioactive resin. Our technology allows an immediate identification of the radiation inside the corridor. It also allows a very good reactivity in terms of decommissioning of the zone at the end of the operations. It's allowed to save time and then money during the shutdown units. It's also a good traceability of the operations thanks to the historics of all the data on our servers. Thank you very much for listening to me. Do not hesitate to contact us. I wish you a good day. Goodbye.
Hello, I am Asénath, presenting on behalf of the Realign team. Realign stands for Robotic Enhanced Automated Landmarks Inspection and Georeferencing for Nuclear Environment Dismantling. I will briefly explain how it works and what does it bring. An autonomous robot navigates a nuclear facility. This robot is equipped with a 360-degree camera and a dose rate probe in order to carry out its mission. The robot is wireless and operated through an HMI using Wi-Fi connection. It can be operated remotely, or it can navigate fully autonomously to discover its environment. During its mission, it will perform dose rate measurement every meter or on specific points and captures 360-degree video. The embedded equipment can be adapted for different missions. For example, we can switch sensors. The scene is analyzed in order to recognize and identify landmarks or specific equipment as valves or fire extinguisher, as it is shown on the video. This is done using algorithms based on artificial intelligence. The identified landmarks allow for measurement positioning adjustment if needed. Identified equipment can be compared to their status in the existing being referential, where any anomaly would be reported. Through the HMI, anyone can access the virtual environment navigating through the 360-degree video with updated data on radiological measurement and status of specific identified equipment. Alarms can be set if an anomaly is detected on a measured value or on the status of an equipment. For example, an opened valve which is marked as closed on the virtual beam. Based on relevant complementary up-to-date data, the user is assisted in decision-making. Additionally, collected data can be used in specialized software. You will now see a video presenting the feature of the Realign solution. The 3 ways to operate the robot. Remote controlled using a joystick. Semi-autonomous with waypoints, we define graphical coordinates on the map. 100% autonomous, the robot knows its environment and chooses its own path. The robot evolves autonomously in a facility. Specific mission routines have been defined for the mission at SPIX. The video is analyzed using an AI algorithm that recognizes landmarks and specific equipments, such as the fire extinguisher here. One can visualize the environment as if you were there. You can access all data with georeferencing and timestamping. You can also visualize them at a glance to detect if there is conformity or any anomaly. You can access detailed information on specific measurement. You will now see a video presenting the features of the realigned solution tested in operational environment at SPIX.